This video, I'd like to talk about pen lifts. That's something that I've been dealing with for a while. It's something that every plotter is actually going to need. I started out, as with many plotters, with servos, and actually that's what I'm going to talk about is servo pen lifts, because that's what I actually have experience of. There's a whole bunch of other pen lifts that you can get. I'm not going to go into those because I haven't got the personal experience, but this is the type that many people pretty much are going to start out with. This is a little micro servo. These are pretty cheap. Get a few of them for $10, €12, whatever it is. You're going to be able to get them by the bag. They are, unfortunately, however, pretty much disposable. These will eventually break. So they're cheap, but they will eventually just die. It's interesting, I've not actually really had the drivetrain fail on many of these. Mostly what seems to die is the position sensor. Down at the bottom of the motor on the output, you have a little potentiometer. I think it's that green part there. And the potentiometer is what's going to tell it where it actually is. And what seems to happen as you're going back and forth and going to pen up, pen down, pen up, pen down, the potentiometer seems to wear out. And then eventually what you will probably find is it will not either raise, or it won't lower, or it won't do it reliably. And then you have the problem, if that's in the end of a massive, great big plot, you're then basically stuck. You may well ruin maybe 8 hours worth of plotting. Serendipity can sometimes come to call and give you a result that isn't terrible, but mostly once that happens, it's dead. As a result, these are pretty good. They will last for a reasonable amount of time. This is what you'll get in most basic kits, but they have some downsides. I ran with these for many years though. I've had some of them last for months. I've had some of them last for years, but they all do eventually stop working in my experience. And so cheap but disposable, which kind of annoys me. I don't like throwing things away that might conceivably be functional, and as a result, I did start looking for different options. So I moved up to the next option, and the next option is maybe something like this. This is a Coreless micro servo. So in terms of size, it's basically the same. Little bit bigger, made of metal, slightly heavier. But fundamentally, this is like this, but more. Coreless refers to the type of motor that it has. So a Coreless motor should have, I think, a little bit less inertia. It should have something that allows it to move a little bit more rapidly. And actually, that was very much what I experienced with this. It was a little bit faster. It allowed you to see the pen going up and down. It was also a little bit quieter. These motors start out relatively quiet, but in my experience, they tend to get a little bit noisier as they go. This one started out, and actually for all the time I was using it, remained pretty quiet. And as a result, I was pretty happy with this. It does need a little bit more voltage nominally. The standard servos are 5 volts. This, I think, wants a minimum of 6. I did run it on 5 volts, and the sky did not fall in, but it may have been run outside of where it was really supposed to be run. The nice thing about these is they are not super expensive. I've been able to find these on the kind of, with promotions, in the kind of £20 mark, which is a lot of money. For that kind of money, you'll get a whole bag of the other ones. But I had the hope that they would actually last a little bit longer, because I'd rather have one thing that I can just keep and use, and then that will just keep running, rather than throwing some away. So I did go for this for a while, and it is a drop-in replacement, which was very nice. A little bit quieter, a little bit faster, a little bit heavier than the others, but still pretty decent. However, the reason why I didn't run from this for a really long time is because the next step up from Coreless is brushless. Brushless servos are, not going to have any wear parts in the motor, but brushless micro servos are incredibly expensive. They're so expensive. And it's more money than I could really drop on an experiment. As a result, I kept going with this for a while until I suddenly realized there's actually no reason why I need to stay with a micro servo form factor. I could conceivably get a brushless servo, which is bigger, full size. And that's where we move over to, excuse me while I bring it in to the shot. This one. This here is a brushless servo, and it's a full-size servo. So if I hold up the other one to compare, you can see how much bigger it is. And it's also substantially heavier. This is a metal body. It's really chunky. I used to have this one mounted down by the side. This one has to go on top on a specific bracket. It has this big CNC aluminium pen arm, sorry, servo arm with, I've actually fitted a little bearing in the end. The pen lift, I will change the angle in a little bit, but the pen lift is lifted up using this loop here, using that. This is probably complete overkill for the job of a plotter pen lift. It has a whole bunch of torque. It's designed to run on really quite high voltage. I think I'm running this on somewhere in the region of 7 or 8 volts. It nominally, I think, wants like 7.4 volts. And that actually brings in, as well as the fact that it's a bit bigger, a bit heavier, it will affect the machine dynamics. That's one of the bigger downsides of these in particular, is you can't run these off 5 volts. Partly because they won't work off 5 volts, I think, but also because these can draw way too much current. If you were to go for the board, hang on, let me just find one. I might cut that out. If you were to run on one of these, this is a clone iBot board. As you can see, it's one that I used to use. It's kind of dusty. This has a servo output here. And actually, you can get a brushless servo signal on one of these other 2 headers here. I forget exactly which one, but I think it's maybe this one, B3. Could be wrong, not sure. But the problem is this is being powered by, I think, this 5-volt regulator there. This is not really designed to provide the current that this thing can eat. This thing can quite happily eat a very significant amount of current. And the regulator on this just isn't going to be able to do it. This little regulator is just not going to be up to it. This is wanting to deliver, you know, in the maybe couple of hundred milliamps. This servo could eat amps, I'm pretty sure. As a result, number one, the voltage is wrong, and number two, the current that it needs if it gets stalled is just far too high. And that's actually one of the biggest downsides, is that you're then going to have to do a whole bunch more messing around to get this thing to run off most of the iBot board based controllers. Actually, even a lot of the other controllers, the more modern ones, are still probably not going to want to provide or drive the amount of current that this thing can do, either at the voltage or the current. As a result, you have to do something else. And what I have done, and I'm going to move this now so that you can see it, so apologies for the shaky camera. What you're going to be doing is something like this. These boards over here are the thing that I've put together really badly, I should point out, to drive that servo. One of these, I forget which one, one of these is being used in order to provide the 7.5, 8 volts or whatever it is I'm running it on it. That is then being fed through into the servo. So effectively what's happening is the signal is coming from here. I'm taking the ground, I'm taking the signal, so that's the black wire, the blue wire, which you can probably just about see. Those come through to this board, and then I throw away effectively the 5 volt that comes into that. I throw away the 5 volts, keep the signal, keep the ground, and then substitute the 7.5, 8 volts from this that then goes out up around to the servo. Is it better? Yes, for sure. It's very fast. It's really quite quiet. It doesn't really make as much noise. I can't really hear the cogs. I can't really hear the drivetrain. So it is very nice. It is very fast. As I say, it works together very well. It does have more firearms on it than I would say is ideal, which is the sense that it has some pictures of firearms on it, and I would rather have none. But with that said, this is somewhere in the region of £35. I got it again on sale. Full price, these are pretty expensive. They're sort of £50 to £70. I did manage to find this on offer, and as a result, it was at the point where I was prepared to drop it as a kind of as a speculative amount, which was pretty reasonable. Again, not cheap, but if it means that I don't need to buy any replacements, that might be a reasonable deal. Another one of the reasons why I'm hopeful that this might last a really long time is that the position sensing for this is claimed to be magnetic, which means instead of a potentiometer, which has a little wiper going backwards and forwards on the track, this should have a little sensor that can detect the angle of a magnetic field, which is non-contact and means there's no friction, there should be no wear, there should be any wear in the brushes, because there aren't any. And so I'm hoping what that means is, because this is, ludicrously underdriven for what it should be capable of doing, I'm hoping that means that it's going to last a lot longer. So those are basically the things that I've done, the things that I've seen, the bits that I've tried. Just as a bit of a recap, you've got your plastic motor, which is plastic little servo, either metal gear or plastic gear, cheap, potentially not going to last that long, has the potential to ruin a drawing right in the middle, which can be super frustrating. The Coreless servo, maybe a little bit faster, can work off a little bit higher voltage, possibly a little bit quieter, maybe last a little bit longer, but still potentially using potentiometer feedback. And then this one, hopefully significantly more longer lasting. Magnetic encoder instead of the potentiometer, so again, potentially longer lasting. Overall, hopefully, this gives an option that is maybe going to last out the machine and allow things to continue. As you can see, though, I haven't tried all of the options. I have not tried stepper motor based approaches. Those can be very subtle. They can give you very good control over the Z height. The iBot boards aren't really compatible with those, so that's a bit of a moot point for me. But I know people who do have CNC boards or 3D printer boards that can drive those. They give them a lot of flexibility, especially for things like brush pens and paint and so on. Those can be really, really nice. The other thing that you get is solenoid based approaches. Those can be super fast, they can be very loud, they can be pretty hard to drive. But again, some of the old vintage machines have those because it's very, very, it's very hard to get faster than a solenoid if you really want to draw very, very quickly. And so those are the ones that I've tried. These are the pen lifts that I've actually been using. Those are the ones I have personal experience of. Overall, if you want to start out with something, go with one of the cheaper ones. Yes, it might fail, but it will get you going. So if you're designing your own plotter, it's probably worth using a kit. These plastic ones are going to be fine. They're probably going to work. Coreless, a little bit of an upgrade, probably going to be helpful. Might be worth going to if you fancy something that might be a little bit quieter, especially if you have to use it around a family who might appreciate the reduction in noise. But then if you feel like it, and if you have the space and you're prepared to deal with the extra mass, these ones can be very, very nice. This was from AliExpress. I'd say about 30 odd, £35 delivered. And I say, depending on the offers, depending on what you get, that might be pretty reasonable. Anyway, hopefully that was useful. This is effectively a very fast tour of my pen lift solutions, and I'll see you on the next one.